All right. So in this unit, or in this part of Unit 8, we're talking about area formulas. And we're talking about the area of a square, a rectangle, a triangle, parallelogram, and trapezoids. I'm just going to make this a little smaller. There we go. So they each have their own separate formula. So you probably want to have some sort of a sheet that has all those formulas in one place so that they're readily available for you. A square, the area is S squared. S stands for the side. So for instance, if I had some square and I knew that all the sides were the same because it's a square, of course, all angles would also have to be 90 degrees because it's a square. This is a regular polygon. And if they told me that the side was 3, because it's a square, I know my formula is the area is side squared. So the area would be 3 because that's my side squared. So my area equals 9. Remember, when you're talking about area, you always have square units. So if the units aren't given, you just put u squared for units squared. But if they said this was 3 inches, then your answer would be 9 inches squared. Remember, when you're writing it, the only thing that's squared at the end is the units, because you've already squared your 3 right here. So that's the area of a square. Now, the area of your rectangle is base times height. So now your base and your height are different lengths. Sometimes people say the area is length times width, and it doesn't really matter because that's really saying the same thing. So if I had some sort of a rectangle here, and I told you that this side was 5 and this side was 8, well, we know that this side over here has to be 5 and this side has to be 8. And we know all the angles have to be 90, but that doesn't really matter to us. The only thing we really need to know is the base and the height. So this here is my base, so I know B equals 8. You could also call that the length. Some people would call that the length. That's fine. And then my height here is 5. And again, some people might call that the width. That's okay. It doesn't really matter. So you're just going to multiply those two together. So now you know your area is 40. And again, it's units squared. So that's the square and the rectangle. Now, a triangle is half of b times h, or sometimes people will write it, you can't really see this very well, b times h divided by 2. Those are saying the same thing. Instead of multiplying by a fraction, you just divide by 2. It's the same thing. And that's kind of interesting because all you really do is you're taking your rectangle and you're dividing it by half. And that makes absolutely sense because if I have a rectangle and I cut my rectangle in half, I end up with 2 triangles. So if you're given a triangle, we'll start here with a right triangle, and they tell you that this here is, I don't know, 4, and this here is 6. Well, the base here would be 6, and the height is 4. So your area formula is 1/2 your base times your height. Well, 6 times 4 is 24, and 1/2 of 24 is 12. So this would be 12 units squared. So the area of this triangle is 12 units squared. But not all triangles are right triangles. So you have to think about some different configurations in your triangles. You might be given a triangle like this. So now the height of your triangle is actually going to be this right here. So the height is always going to be your altitude, if you remember. Pretend this is straight. I didn't draw it very straight, but you get the idea. So the height is always going to be your altitude. It's always going from one vertex to the opposite side at a right angle. So that would be your height. So if I said that was, I don't know, 3, and I said this here was 12, then my area would be 1/2 3 times 12. I don't care what these two sides are. If they labeled this side as 6 and this is 8, I could really care less. For my area, the only thing I care about is the height and the base. Now, be careful because your altitude can be drawn to a different a different side, for instance, I could draw my altitude. I'll have to turn my box because it's a little hard to draw it. If I drew it from like here, I can't draw that well, but if that's my altitude, and it said that this here was 2, and that's not a good example. I'm sorry, let me try that again. You have to draw it from, maybe I'll do it from this one here. This would be better. So if I do it from here over here at a right angle, now this would be my altitude. It goes from a vertex to the opposite side at a right angle. And so if they said this was 8 and I don't know, this was 4, then it would be 1/2 8 times 4. So always look for the height as being from a vertex to the opposite side at a right angle. So kind of look for that right angle symbol. And then what this symbol joins is the altitude and the base. So that's kind of how you know which base to use. So that's the area of a triangle. Very similar when you're talking about the area of a parallelogram. The formulas look the same, but once again, h has to be in altitude, just like it does have to be in a triangle. So if I have a parallelogram that's going to look like this, again, if I have a height that goes from a vertex to the opposite side at a right angle, this here would be my altitude. So that's going to be my height. And then this altitude is connected to this side. So this here would be my base. So when you're looking at a parallelogram, you always have to look for that altitude, just like you did in a triangle. So now if I said this altitude was 5 and this here was 10, then the area would be base times height, which would be 5 times 10, which would be 50, again, units squared. All right. And the last one is a trapezoid. And sometimes you'll see the formula given like this, 1/2 B1 plus, whoops, I forgot the H, 1/2 H B1 B2. But again, sometimes kids don't really like dealing with the 1/2, so they prefer just to divide by 2. It's the same exact thing. So now you have a trapezoid. And if you remember what a trapezoid looks like, it has one pair of parallel sides. And what you're going to do is these parallel sides are called your bases. So this could be like base 1, and this here could be base 2. It doesn't really matter. You could just as easily call this one base 2 and base 1. It doesn't really matter because you're just adding them together anyways. So it doesn't really matter which one you call it. But once again, this height in the formula has to be an altitude. So you have to look for it coming from a vertex to the opposite side at a right angle. Now, in this case, it looks like this one also here comes from a vertex to the opposite at a right angle. So sometimes it's part of the trapezoid, but most often it would be kind of inside the trapezoid, and it's usually indicated by a dotted line, but again, not always. So let's say they said this was 4, and this was 8, and this was, I don't know, 3. Then my area formula would be h times b1 plus b2 divided by 2. So in this case, my height would be 3. B1 would be 8. B2 would be 4. Again, I could have switched those. It would make no matter. I could have said 4 plus 8. And then I'm going to divide that by 2. Well, 8 plus 4 is 12. So I can simplify that. 3 times 12 would be 36 divided by 2. So my area, I guess I have to write it over here. My area would be 18 units squared. And I just want to show you this one example that's in your worksheet right here. Sometimes the height can be outside of the figure. So the figure is actually this right here. This here is your parallelogram. But this goes from a height to the opposite side. So this here is your height, but only this length here is your base. So this would be 12 times 17, would be the area of your parallelogram to get 204. And this trapezoid is just kind of like the one I drew, except it's just kind of turned on its side. If you turn my paper over this way, it looks a little bit more like the one I drew, where this here is your height, and this would be B1 and B2. So if you have any questions on any of those formulas, let me know.